Good morning, I'm Sarah and today we'll be studying nomenclature of compounds. Now nomenclature is basically the naming of compounds. Like you and I, we have our formal names or our legal names which are written in our documents, in our Aadhaar cards. Similarly, compounds have their formal name which is written according to the IUPAC rules. IUPAC. Now, IUPAC is an international federation which was founded in 1919. It is part of the International Science Council. IUPAC is International Union of Pure and Applied Chemistry. Now, according to IUPAC rules, the nomenclature has three components, which is prefix, word root, and a suffix. Okay. Now prefix are of two types, primary prefix and secondary prefix. And we also have suffix of two types, which is primary suffix and secondary suffix. Primary, secondary. Now when you're making your notes or you're solving anything, you can use these symbols, but otherwise if you're writing an exam, you should write the full name, which is primary. Don't mention the symbols then. Secondary, prefix. Now primary prefix is basically the substituents or the branches present in the compound. There are atom or group of atoms attached to the main chain of a compound that will be represented by the primary prefix. Primary prefix is basically the branches or the substituents. For example, if we have chlorine atom which is attached to a main chain, we'll call it chloro. Now there are special structures of compounds which are cyclo, bicyclo and spiro. They are represented by the secondary prefix. Cyclo, bicyclo or spiro. Okay. Then we have our word root. Word root is basically the number of carbons in main chain. I'll write it here. Number of number of carbons in main chain. Okay. Then we have suffix. Suffix are of two types, primary suffix, secondary suffix. Primary suffix basically tells us the type of carbon-carbon bond present in the compound. Now what are these type of bonds? These can be single bond, double bond and triple bond. Primary suffix tells us the type of carbon-carbon bond. Secondary suffix is basically the function group which is present in the compound. Okay. Now all the compounds are written according to this flowchart and in the same order. First we write the primary prefix, secondary prefix, word root, primary suffix and then the secondary suffix. Our nomenclature is basically learned by doing examples, but we'll do a little bit of theory that you need to remember beforehand. And so the first component we knew is prefix, and in the prefix, we write the primary prefix first. The primary prefix was the substituents. Now substituent are the atom or group of atom which are not in the main chain itself. They are not in main chain. Whenever you write the substituent, the position at which the substituent is present should be mentioned. Always mention position. We will learn all this with examples, and I'll give you some examples of common substituents and what their names are. We have NO2. This dash basically means the bond which is which connects the substituent to the main chain. This is the main chain, and the bond, this dash basically represents the bond between the substituent and the main chain. NO2 as a substituent is called nitro. Then we have nitro, we have X. X basically is the representation of all the halogens. Halogens are are the atoms of the group of fluorine, chlorine, bromine, iodine. Okay. Halogens are called chloro, bromo, iodo, fluoro. These are chloro, bromo, fluoro, iodo. Then we have single nitrogen attached to oxygen. This is nitroso. Then we can have N3. N3 is basically azide, and as a substituent we call it azo. This is azide, and we name it azo in the substituent. Now these are some example of the heteroatoms which are connected as substituent. We can directly also have carbon chains which are attached as branches or substituent from the main chain. R basically represents the alkyls. Now in alkyls, the name can differ according to the number of carbon atoms present in the group. If we only have one carbon atom as also, always remember we are talking about one carbon atom. We have one bond present already. Always remember to fulfill the valency of carbon atom. One is done, we have 3 left. So that will be fulfilled by, in an alkyne, it will be fulfilled by hydrogen atom. So it will be CH3. Now one carbon alkyl as a substituent will be called methyl. C2 will have carbon, fill the valencies, H3, H2, which is C2H5. This is called ethyl. If you don't remember the number of hydrogen, in the beginning you can always separate the carbon atoms, and as you keep practicing, you will always remember how many carbons will have how many number of hydrogen atoms. For C3 we have H7. This is called propyl. Now there is another structure. Propyl can be of different types. Propyl can have all the carbon atoms in the same chain. See, H3, H2, H2. When all the carbon atoms of a chain are in the same line, it is called N. We attach N propyl. And if all the carbons are in same line except one carbon, which will be attached to the second last carbon, H3, H3, H. This is called isopropyl. And in a structure, if all the carbon are in a chain, but two carbon atoms are attached to the second last carbon, this will become neo. Okay. More substituents are a chain directly attached to oxygen atom and R. These are called alkoxy groups. Alkoxy groups. Now, alkoxy groups can also differ according to the size of the alkyl present. For example, if we have OCH3, this will be called as methoxy. OC2H5 will become ethoxy. Similarly, if we have OPH. Now this pH is basically a representation called phenyl. Phenyl is basically a benzene ring which has one valency open to connect. This is phenyl group. And this will be called as OPH will be called phenoxy. Phenoxy. Okay. And these are the primary prefixes, which are the substituents. We'll study the secondary prefixes later. After the prefix, we have word root. Which is basically number of carbon in main chain. Main chain, which is basically the longest chain. The first rule to find a main chain is that it should be the longest chain possible. Now for word root, you should remember these. 1, 2, 3, 4, 5, 7, 9, 12, 13, 20, 20, 21, 22, 30. We don't really need this much. So a word root which has a compound which has main chain having only one carbon compound, the word root for that will be meth. Is it visible? Meth. For 2 we have eth. For 3 we have prop. But for 4. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non. 10 is dec. You should absolutely remember all these word roots up till 10. These are necessary, and rest you also need to remember some of them. Okay. 11 is going to be 11 is undec. 12 is dodec. tridec, and similarly we'll keep going as 14 is tetradec, 15 is pentadec, 16 is hexadec. Then 20 is going to be ICOS. 21 is going to be henicos. Henicos. 22 is docos. Similarly, we'll keep going on, and then 30 is tricont. Okay. It is mandatory to remember up till 10 number of carbons, and then rest you can remember as you do the examples. Now for primary suffix. What did primary suffix represent? Primary suffix meant the type of carbon-carbon bond present in the compound. The carbon-carbon bond in main chain. We only have 3 types of bonds which can be possible. Single bond, double bond, triple bond. Single bond will be ane, double is going to be ene, and triple is going to be ine. These are the representation for primary suffix. Now we'll do rules of nomenclature. For secondary suffix, I'll give you an example. Secondary suffix. You don't have to understand this right now. This is just a way of remembering. Now, secondary suffix represents functional groups. The functional groups basically have a priority list as well. The priority list is basically, we have acids as COO. Acid means carboxylic acid. We have COO. Then we have ester. Then we have acyl. Then we have amide. Then we have cyano, triple bond N. Then we have aldehyde. And then we have ketone. Ketone afterwards we have alcohol. We have thiol, amine, we have double bond, triple bond, double, triple, and we have single bond, double, triple, single. We have ether, and then we have halogen and NO2. These are the priority list of functional groups, which means if we can always have multiple functional groups in a compound. the priority list basically tells us which of the functional group is going to be the main functional group. If for example we have an acid and we have cyano, if these two functional groups are present, only one of them can be taken as a secondary prefix. The priority list will tell us acid has a more priority, so the acid will be treated as the functional group and the cyano will become a substituent. Okay, this is acid, we have acid, ester, acyl, amide, cyano, aldehyde, groups of ketone, alcohol, thiol, amine. These are double bond, triple bond, single bond. We have double, triple, single bond of ethers. Ether, halogen, nitro. You can remember this by, this is not a true statement, but you can remember this as, according to esters, acyl and amide are cyano groups of aldehyde ketone. We can write this as, according to esters, acyl and amide are cyano groups of aldehyde and ketone. Now this is not a true statement, but it's a way of remembering. A means acid, then we have ester, then we have acyl, amide, cyano, aldehyde, ketone. We've remembered half of the priority, and then we have alcohols, thiol and amine are double, triple and single ethers of halogen and nitro compounds. We have alcohol, thiol, amine are double, triple and single ethers of halogen and nitro compounds. It's not a true statement, it is just a way of remembering the secondary suffix. Now we have rules of nomenclature. Rules of nomenclature. Now rules of nomenclature we'll do according to examples and everything. So rule number 1 we have, select the longest whenever you see a carbon, whenever you see a compound, these rules will be followed to name the compound. The first thing you should notice is select the longest carbon-carbon change. It does not need to be a straight chain. Select longest carbon-carbon chain. Need not be straight. Now, for example, we have 2, 3, 6, 7, and now we have to find the longest chain in this. There are two options. Either we can take this whole chain, 1, 3, 4, 5, 6, 7. This is 7. But if we count this instead, we'll get 5, 6, 7, 8. So which is going to be the main chain? I just said the longest chain does not need to be a straight chain. So we can select the one which has more number of carbons. So this is our main chain. Okay.